So here we have another pulley problem where we have two masses, a mass A and a mass B, that are connected with a cord and various pulleys, and we're asked to find the accelerations of A and B and determine the velocity and change of position of B after 2 seconds. So we're given some other information in this problem. Block B starts from rest and moves downward with a constant acceleration. We know that A has moved 9 inches and has a final velocity of 6 feet per second. So what do we do? Well, since it's a pulley problem, a good first step might be to establish our reference datums and try to figure out the relationship between the acceleration, the velocity, and the positions of A and B. So if we start by figuring out our reference datum from a fixed point. This is a pretty good point. It's fixed. We're going to be interested in B, so what the distance of B is. So we'll call this S of B, and A is moving in a different direction, so we need a different reference, and this pulley is also fixed, so we can call this our S of A, and notice that we're saying downward is our positive direction and to the left is our positive direction because we're referencing from this point. The other thing we have to realize about this problem, that we have this length of SB, and when we're looking at this rope, it's fine for this rope and this rope, but what's the length of this rope? When we look at this, the distance here I'm going to call H, and H is a fixed distance, it's a constant. So the distance here from this pulley to this pulley is a constant distance. It doesn't change with respect to time, so we can call this H. So now if we go through and trace our chord, we have SB plus SB, and then we have this length of this chord, which is SB minus H plus SB minus H plus the length right here. So this is SA, and this is equal to some length. We can clean this up a bit and get 3SB minus H plus SA is equal to some length. And when we differentiate with respect to time to get the velocity, we get 3VB plus VA is equal to 0. The H right here and this L, they turn into a 0 because they're constant, and the derivative of a constant is 0. And when we take the derivative of this equation right here again, we can get 3 times the acceleration of B plus the acceleration of A is equal to 0. And this is the relationship that these two the accelerations of these two blocks have. So we need to figure out either the acceleration of A or the acceleration of B and use parts of the information that the problem gave us to figure that out. So what do we know? We know that block B starts from rest, so that also means block A has to start from rest. So we have initial velocity is equal to 0 and moves downward, so block B is going to be moving downward with a constant acceleration. This is an important piece of information because constant acceleration means we can use our kinematic equations. And what are these equations? These equations are right here. The final velocity is equal to an initial velocity plus an acceleration times time. The final velocity squared is equal to an initial velocity squared plus 2 times the acceleration times a final position minus an initial position. And the final position is equal to an initial position plus an initial velocity times time plus 1/2 times the acceleration times time squared. And if we keep going, we know A has moved 9 inches. Units are important here, and its velocity is 6 feet per second. So we know X is going to be 9 inches, or we know this is 9/12 of a foot, and the final velocity is equal to 6 feet per second. What else do we know? We're looking for acceleration, and this problem does not state anything about time. So using our kinematic equations, this is not a good one to use, and this is not a good one to use because these both need a certain time. So if we plug in our numbers right here into this kinematic equation, we get the final velocity, which is 6. 6 squared is equal to the initial velocity, which is 0, since it starts from rest, plus 2 times the acceleration of A. That's what we're solving for. And we're solving for A because all our information right here is about block A. And the change in distance is 9/12 of a foot. So our initial, we're calling our initial X position 0. So if we solve for A, we get 24 feet per second squared. And we aren't quite done just yet. If we look at this equation, we notice that the acceleration of AB plus the acceleration of A is equal to 0. So this means that either B has to be positive and A has to be negative, or AB has to be negative and AA has to be positive. Now, we don't know which one this is, and when we solve for the acceleration of A, we're going to get a positive number because of the square term right here. Because even if this was a negative number, when we square a negative number, we're going to get a positive number. So we're not sure. There's some ambiguity right here. But luckily, this problem tells us that block B starts from rest and moves downward. So we know block B is moving downward. And thus, we know that B is going to be our positive value. So that means A has to be our negative value. So A is minus 24 feet per second squared. So now that we have the acceleration of A, we can plug it back into this equation right here, and we get the acceleration of B is equal to the negative acceleration of A over 3. So this is the negative acceleration of negative 24 over 3, and this becomes 8 feet per second squared. And notice this is our positive value. So this means that B is moving down and A is negative, so A is moving to the right because it opposes our positive convention. So the acceleration of A is 24 feet per second squared to the right, and the acceleration of B is equal to 8 feet per second squared down. So now what's part B of this problem? Determine the velocity and change in position of B after 2 seconds. Well, we can again use our kinematic equations. We can use the two equations we didn't use before because we now have a time. And for the velocity, we have a final velocity is equal to initial velocity, which is 0, plus the acceleration, which is 8, times time, which is 2, and we get the final velocity is 16 feet per second, and it's positive, so this is down. And likewise, we can, for the position, we can look at the position is equal to the initial position, which we can call 0, plus the initial velocity times time, which we can call 0, plus 1/2 the acceleration, which is 1/2 times 8 times time squared, and this becomes a 432, 16 feet. And again, it's positive, so it means block B has moved 16 feet in the downward direction.